Why not? Why the 56.3?
Oh, yeah.
Yeah. You've got to be paying attention. What's this one you said? 56.3? So what we want the rotation, which is outside the triangle. Well, how do I get that? Yep. And not that I can do that in my head. 133? 123. Dang. 123.7 is the direction. Questions there? Cruising right along? Okay, let's go backwards from this one.
We're going to find the point.
Right. The vector in pointed bracket AB form if the magnitude of vector C is 8.8 and the direction is 215 degrees. Yeah, it's alpha, it's the Greek letters. Remember, the Greeks like to use those, those Greek letters for the angle measures. I could use a theta, I can use anything. Okay, remember the AB is like an ordered pair. I'm looking for the ordered pair, the endpoint of this vector. Well, which quadrant is this vector C in? If it's got a 215 degree rotation. 3? I think so too. Notice how I use all the information and I label the picture. 215 is this rotation. That's how I get into quadrant 3. 215 degree rotation. The C is 8.8. So what I am looking for is this endpoint. And you can always make the right triangle when you're on the coordinate plane. And the legs of the right triangle are going to give me the A and the B, my X and my Y. So I am looking for this and this. A and B. Got the 90-degree angle. We've got the 8.8. I'm missing a third piece of the triangle. How do I figure it out? The angle inside the triangle can be found by taking 215 and subtracting off the 180 that's on the outside. So 215 minus the 180 leaves us with how much inside? 35 degrees. So 35 degrees in here. That's a bad 3. And now you're ready to run which program? Angle side. And then your goal is to interpret and fill out the A and the B from the 3 answers that the program's going to give you back. What did you get for the A? 7.2 correct?
Yeah.
Is it really, really correct for A? Are you sure?
I got 15.3.
I think you're wrong. I think it's 7.2, but does anybody know what I'm getting at here?
Negative.
Negative. The program's never going to tell you a negative. It's solving triangles. They're always going to come up positive. Your picture says that the A is in a negative direction. Because remember, this is an ordered pair here. So I need to supply the negative to it. And then what's the B? Negative, tell me again? 0.0? All right, Kurt, did you figure it out? Did you put the angles in the wrong order? That's the only one you can mess up is angle side. Okay, and any negatives have to come from the picture. That's why you need to draw the pictures. I think it's helpful. Okay, last one. No, these aren't bad. I think the story problems get challenged tomorrow. I think we'll have our quiz on Thursday. before Christmas break. Well, we're done, we don't have class on Friday, so, it kinda worked out nice. We have 3 story problem days, I always do, Wednesday will be review, Thursday will be the quiz, and we come back,
So the
starting
rest of,
chapter
like,
5,
So
so.
the rest of all of this is basically just like us doing the same thing, but like
Yeah.
story problems?
Yes.
Are we still gonna have notes every day?
Yep, we'll do a few together.
Okay.
Karaoke, I heard it's not happening anymore. It better. I will be so sad. Wow, good job, Dylan. Oh, wow, easy. You too.
I don't goof, it has it.
I've just been using that.
I've been using that for like 6 years, so.
Yeah, Hayes has been using that.
That's who I know.
Okay, we want to find, listen, the angle measure between the 2 vectors. This is our last one. So, obviously, we're going to graph both of them, and we want to be able to find the angle between the 2 of them. So, where is U at? That's in quadrant 3, and V is in quadrant 4. So, I need the bottom 2 quadrants. So, -6, -2, and then we want 3, -1. Okay, and when we talk angle between the vectors, we want the shortest angle between the vectors. We don't want this big rotation on the outside here. So we want, our goal is to find this angle measure right in here. Well, how are we going to do that? Because we don't know the length of the 2 vectors, we're going to work with the 2 right triangles that go with each vector. So, think about this for a minute. I want to make a right triangle with this vector here. I could go back to the x-axis and be okay. But it might be a little more clever of us to do what? Go to the y-axis, because then I can find the angle here. Do the same thing with that other one. If I connect back, because my angle is kind of going over the y-axis, not the x. I can find this angle here, and then we can add the 2 together. If I had went and connected to the x-axis, then I would have found angles above, then I would have just had to subtract from 90 to get the ones below here. We could have done it, but it would have been more work. So, being a little bit more clever, we save ourselves a step. So this triangle here, what do I know about this triangle?
The 2 horizontal, or the vertical and horizontal.
Yep, I know the vertical and the horizontal are a 6 and a 2. So you can run a SAS with a 6, a 90-degree angle, and a 2. Again, we're solving a triangle, so I threw away the negatives. So what's the angle measure across from the 6? 70 what? And then over here, we got the same thing. We got a 3, a 90, and a 1, so we can run SAS on this one. And we want the number across, the angle that's across from the 3.
70.
How did that happen?
It's just scalar multiples of each other.
Yeah, they're scalar multiples of each other. I didn't catch it the first hour, or second hour, till I looked at, like, why did they come out the same? Because one's just double the other one. So it's like they're similar triangles, so the angles didn't change. So the angle between them, you just add the 2 together, 153.2. 143.2. Jeez. Not very good. Okay, your assignment is in red on this one, so I guess I'll write it again. Page 310.
Is it really long again?
Yes.
No. What do you call really long?
More than 4.
More than 4, then yes, every assignment in here is long.
What about more than 10? Well, there's already more than.
Remember I said, all you had to do was draw the pictures, you write the program name down, and then you would just tell me 6, 90, and 2, then you're done. That counts as full credit. So I don't want you to take my calculators out. I've already lost 4 of them. I'm hoping they come back. But I don't want any more leaving the room. So, well, usually I don't lose them. I mean, there's 4 gone already this year. So hopefully people are honest and bring them back.